Okay, this is for factoring by grouping. So this time, as we factor, we are looking at the number of terms in the polynomial. So we're going to start with a 4-term polynomial. And when we do that, we factor in groups, which is also called factoring in pairs. Remember that we're trying to break this into 2 smaller pieces to factors, and so we want to do this. This is an easier thing when a polynomial has 4 terms. And as we do this, so that we've done factoring by using the greatest common factor, now we want to do it by pairs, so we always check in order for a greatest common factor. So when you look at a polynomial that has 4 terms, we're going to look at the first 2 terms and then the last 2 terms, and we look in groups to see what we can do. And you can see that in the first set of terms, the GCF will be x squared. And that leaves me with x plus 7. And then in the second 2 terms, I can take a 2 out of both of those, and that leaves me with x plus 7. Notice that as we do this, that now I have this common term. And so I can rewrite my polynomial all the way through as x squared plus 2. That comes from here and from here. And then my other term that I factored out becomes my second factor. And again, to check, we need to FOIL or distribute. So I can take x squared times x and x squared times 7. And then I can take 2 times x and 2 plus 7, and I should end up with my original polynomial. So let's do some examples. So when I look at the first, I'm going to break it into 2 groups. I'm going to do this one, and then I'm going to do this one. And remember, we don't want negatives inside the parentheses, at least not the first one. So I can divide both of these terms by x, or no, sorry, y. So that I'm left with y times x minus 5, and then on this side I can take out a negative 2, which leaves me with x minus 5. So there's the first step of factoring out the GCF. And then we take it and we say, okay, this piece and this becomes y minus 2. And then this piece and this piece becomes the second factor of x minus 5 because it's in both terms. So here I can divide by x squared. And here I can divide by negative 8. So then I have x squared, which is x plus 5, and then I take out negative 8, and that leaves me with x plus 5. Notice that because I divided by a negative 8, negative and a negative becomes a positive. Keep your signs straight. So then we take the 2 terms that are outside, x squared minus 8, and then the other term that's in parentheses that's in both terms, that's a common factor, and that becomes x plus 5. So here I can factor out a 4 and an x. And here I can subtract out a y. Or divide out. Subtract out. Divide out. So that leaves me with 4x times 2x plus 3 plus y, 2x plus 3. So then I take my outside terms, 4x plus y, and I multiply them times the other common term in parentheses, 2x plus 3, and I have factored my polynomial. You go through the steps and see if you can get d plus 3 and c squared minus 7d for number 5. All right, so when we look at number 6, I have to factor out a GCF first. So I can divide every one of those terms by 2. So I'm going to take a 2 out, and that leaves me with 2ab squared minus 8b squared minus 4 plus a. And then when I look at that, so that 2 stays, and then I can take a 2, I can divide this by 2b squared, so that leaves me with 2b squared times a minus 4, and then I can turn the other one around to plus 1a minus 4. There's a 1 right there. So all I did here was turn this around, and then 1 times anything doesn't change anything, so I have to put a 1 there. So when I finally finish, I have 2, and we take our outside terms, 2b squared plus 1 times a minus 4. So then we look at number 7, and what can I take out of all those terms? A 3. So I can do 3, and that leaves me with 2n cubed plus 5n squared minus 4n minus 10. And then we're going to look at the first group, and I can divide out an n squared from both of those, and I can divide out a negative 2 from both of these. That leaves me 3 times n squared times 2 plus 2n plus 5, and then minus 2 n plus 5. 2n plus 5. Remember, I'm trying to make these two things look the same, so that's how, as I went through and made a mistake, then I need to correct it. So 3 times outside n squared minus 2, 2n plus 5. All right, so sometimes we get 4-term polynomials, which is what we're looking for when we're looking to factor by grouping. But when you look at it at first, like, I can't factor anything out of here because I can't get a 2, but maybe I just need to switch these terms so that these switch places. So if I rewrite this as x squared minus 5x plus 2xy minus 10y, then I can see that I can divide this one by x and these by 2y. And then you can see that when I divide, I'm going to get a 5 and a 5. So I get x times x minus 5 plus 2y x minus 5. So I end up with x plus 2y, x minus 5. So again, it usually ends up being the middle two terms, not always, but usually. And so I'm going to just switch those because then I have my a's together and it works better. So I have 10ab minus 15a plus 21 minus 14b. Excuse my loud cat. Shh. So then I can divide the first two terms by 5a, and I can divide the second two terms by 7. So I have 5a, and when I divide, that leaves me with 2b minus 3. And then I have plus 7 times 3 minus 2b. But see, that doesn't quite work. So I need to change some signs. So to change signs, then we get 5a minus 7. And if I change that to a negative, then I got to change all of those. So if I change one thing, you change everything in the problem. That becomes minus, or not like that, times 2b minus 3. So I switched the signs. So I had to change this one, which means I had to change these to match over here. Last one. So I'm going to change these middle two terms so that I have 24m squared plus 6m plus 56mn plus 14n. And I can divide this by 6m. And I can divide this by oh, I'm doing this backwards. I missed a step. Gotta get my greatest common factor out. Yeah, hold on. Okay, let's take out a greatest common factor first. So I can take out a 2. That leaves me with 12m squared plus 3m plus 28mn plus 7n. Now I can divide. I can divide this by 3m, 3m. Divide this by 7n and 7n. So I'm left with 2 times 3m, 12, 4m plus 1 plus 7n, 4m plus 1, 2, 3m plus 7n, 4m plus 1.